Welcome to the fluids assignment. So, task number one, you've done this already, I hope, on a loose leaf. So, remember those questions. You can get the answers from the recorded DI on fluids. Now, let's now get into task number two, which is the problem solving part. So, here it is. Now, remember the triangle formula that we had when we dealt with density, when we had that unit on the water systems, it essentially works the same way. So if you have any three variable in a formula, one can safely use the triangle strategy. So how does this work? So here, for instance, we have the variables F for fluid for force, A for area, P for pressure. So here, for instance, whatever you're looking for, you kind of close or put your hand over it so that if two variables are side by side, that would mean to multiply. Let's say I'm interested in the force. So I cover up force. The remaining one would be what? Area and pressure side by side. That means to multiply. Now if I'm looking for pressure, for instance, I cover up P here, or pressure, have F on top, numerator, A down, denominator. That's why you have the formula here. Pressure is force over area. And if you're looking for the area, for instance, cover up A, you are left with F and P. F in the numerator and P in the denominator. So that would now be area equals force over pressure. And you know by now that when we deal with numbers, when we deal with problem solving in science, we are very much interested also in attaching a unit of measurement to any number. So if you see a number and the unit of measurement would be in Pascal or PA, that would mean a unit of pressure. Or if you have area, I know this is very much familiar in math, right? So it's the dimensions of an area or a location, maybe, or even that of an object. So here, if you see units of meter by meter, right, or meter squared, then you know you're dealing with the area. Now, force, of course, would be the big N here. It means Newton. So, with that in mind, let's now have this set of problems here. Again, on your end, if you see this, right, click on present on top. Can you see that? So, click on this so that it's on a bigger scale that you're saying. And from here, everything is kind of magnified. So, if I click on this, I am brought to a Google Docs, and this you can safely just type in numbers and everything, and you can see from here I have the triangle formula to help you out with every problem. Now, under solution here, if you care to notice, there is a hyperlink here. It calls on screen an online calculator, but you're free to use your cell phone maybe, or whatever calculator that you may have in the room. But I find it best to just use this online calculator. Now, let's now deal with the first problem here. So let me just make a demo, okay? So it says here, a football player is tackled by another player and lands with the combined weight of both players, ouch, on his knee. If the combined weight of the players is 2400 N or Newton, and the player's knee measures zero point 0.1 meter by zero point 0.1 meter, Again, let me just put in a focus mark here. Yes. How much pressure is exerted on the turf when the player lands on his knee? So here, the GRS strategy again, given, required, solution. Given is what you see on the problem. So look at all the numbers. So for purposes of this demo, I just put in different colors, right? So 2400 N, what is N? Newton, it's a unit of force. So F equals 2400 N. What else? What other numbers do you see here? Zero point 0.1 meter by zero point 0.1 meter. Meter squared, a unit of area. That's why I have here A equal to zero point 0.1 times zero point 0.1 equals how much? Can you do mental math? If not, then you can just click on your online calculator here and then you can just type, oh, what did you have there? 0.1, right? Times 0.1 equals 0.01. So let us get back to this. So you can just type in here 0.01. And of course, we have meters squared, okay? Meters squared, M2, meters squared. Now, and it's clearly asked, right? How much pressure? So P is being asked. And of course, P should have the unit on. What's the unit? So you can then scroll up and see. So it must have the unit of Pascal. So you can say, be more complete. So P in Pascal. P, capital P, small a. So that's how we write down the unit of pressure here. So solution. You always start with a formula. So look at the triangle. You're looking for P. So I need to cover the P here. And I'm left with what? F over A. So I'm looking for pressure F over A. So I'd better just copy this one. Cut and paste, right? And say Control C and then you scroll down. And then put it here. So you now have the formula there. Once you have the formula, then make sure everything is aligned. So you can have P equals, then it's time now to substitute the values that you have. You go back to the given. F, do I have F? Yes, it's 2400 N. So copy that down. So you can say 2400 N divided by what? A. What is A? 0.01. So you can write there 0.01 meter squared. Okay? Okay, so let's continue. So you can use the online calculator or you can use your cell phone. So what do we have here now? So if you have 2400 N or Newton divided by 0.01, are you guys getting the same answer as me? So it's now 240,000. What's the unit? Should be in Pascal. Okay, there you go. That's problem one. Now, in class today, we also went over the number two problem here, right? So the same run of things. So for purposes of this demo, again, I just put a color to the numbers that we're seeing in the problem. So for number two, for instance, you have a force of 2000 N. So that would be the F. And what else? You have 0.02 meter by 0.01 meter. So meter, that's what? meter squared. Now, of course, you need to correctly just do the unit right. And I think I introduced this in class. Let's say, so let's try and remove this first, okay? Just to kind of refresh people on at home on how to do this. So let's say you have here M2, right? So how do I make this as an exponent? Again, under tip of the day, so you can just highlight this, right? And let's see what we have here. Go to format. So click on format, go to text. So superscript is the exponent, right? So that you would be able to do this. So highlight it first, right? Again, let's repeat that. So click on format there, then text, right? And then superscript so that you can have it correctly written as this. So force is now 2000 N or Newton divided by 0.02, and this was the answer that we got. Try it out. Are you getting the same answer? I hope. Okay. Now, you were asked to do the rest of the problems, but interestingly, I would want to go for the last problem that we have here because you might notice that we have a different unit here, which is now on kilogram. Remember that before force is usually in Newton or N, pressure would be in Pascal, A commonly would be meter or meter squared. So let's try and deal with this problem that we have here. So again, for purposes of this demo, I just add everything in color again. So it says here, a charity fundraiser fits 12 students into a small car. If the combined weight of the car and the students is 1,600 kilogram, so you might notice, this is a unit of weight or even mass, right? So if that's the case, would you think that this would be force? Not really. So let me introduce you to this new concept now, okay? Another way of getting the force, let me just put on the focus mark here. So another way of getting the force, or F, so can be done using this formula. F is equal to mass times G. Now allow me to introduce a new concept here, G as the acceleration of gravity. You can think of it as another constant, and it has a value of 9.81 meter per second squared. What are the other constants that you know? The value of pi, right? Pi is 3.1416. So the same thing with acceleration due to gravity. So it says here the weight of an object is defined as the force of gravity on the object and may be calculated as the mass times the acceleration of gravity. F is equal to mg. So in the problem that we are discussing, m, or the weight, is 1,600 kilograms. You need to multiply that by the constant g, which is 9.81 meter per second squared. Now, if you multiply the two, I hope this is the correct value that you're getting, right? So 1,600 multiplied by 9.81, I'm getting 15,696, right? Now, notice the unit here now, kilogram meter per second squared. Now, what is this? This is actually the long version of our unit on Newton. Newton really is kilogram meter per second squared. So actually, this is the value now for your force. So maybe let me just copy this. And let's go back to our problem here. So here, the force, this is now our force here. This is, maybe just make it smaller. So again, let me just go there. And the unit here is kilogram meter per second squared or Newton, capital N. Okay? I want you to just process that. Or you can always go back to this video clip. Now, what else is given here? The area is what? Oh, we don't have any problem here. It's already calculated for us, or it's given in the problem. So let me just cut and paste that. Control C, and then I am here. I forgot the 2 there. Okay. Now, we have FA. What is S? What is the pressure? So P, again, is S. And what's our unit for pressure? Yes, it is in Pascal, PA. Now, how do you solve again the problem? So always go for the triangle, right? You can't go wrong with the triangle formula, okay? So here, P is S, so that would be F over A. So we're looking for pressure, so you can just copy this. And sometimes the worst scenario would be you get mixed up with dividing or multiplying, right? So just be very careful. So here, you now have this as our formula. Now, plug in the values that you have. Just move it down so that you get to see it. So here, pressure now is, substitute the values that you have. Force, 15,696 Newton divided by A, which is 0.08 10 meters squared. Now you can use the online calculator, but if you have your cell phones with you, I think that would be faster, right? So I have here 15,696 divided by 0.08 equals sign. I have here 196,200. Once again, the unit, it would be in Pascal, okay? So I want you to be very comfortable with using our formulas, using the triangle method, okay? So give it a try. And again, if something is in kilogram, just to make a recap, you need to remember this alternative formula. F is equal to mass, the one that you see as kilogram. You need to multiply it by the acceleration due to gravity, which is 9.81, okay? So that you can get the value for the force, which is in Newton. Again, Newton, the long unit for that would be kilogram meter per second squared. Okay, so I'll stop at this. So give pressure a chance, right? So do this. I know you can do this. Thank you. Ciao for now.